Okay guys, so now let's move to the next question. So we're given a statement there. They say the switch in the circuit is now opened. So let's see, where is the switch? So this is where we've got our switch. So now they are saying the switch is now opened. So you should know, I think if you've watched from the first question, you will realize that we've got a parallel connection there. And again, remember guys, we've just indicated that the combination of these two, the effective resistance of this combination is the smallest of, it's smaller than the smallest resistor. So you can see 6 was the smallest resistor. So the effective resistance, it's supposed to be a value smaller than 6. So now when you open this switch, it's more like you are now converting this connection from parallel connection to series connection, because there's no current flowing through the 15 ohms resistor. So that means all the current is now flowing through the 6 ohms resistor. So it's more like you've increased, it's like in a way you've increased the total resistance of the circuit, because you no longer have that effective resistance which is smaller than the smallest resistor. It's now a 6. So that's why I'm saying in a way it's more like you've increased the total resistance of the circuit. And again, remember guys, this V I just added it when I was busy with the previous question, so that you've got an idea of I think we're supposed to calculate the effective or the potential difference across the parallel combination. So that's when I drew this V. So okay, let's see now. Let's move to question 10.1.5. So now remember, now this the switch is opened. So the question says, how will the reading on the voltmeter V be influenced? So you just choose from increase, decrease, or remain the same. So for you to be able to answer this type of questions, guys, you need to have a background of the circuits. Just like I've explained, I've indicated that it's more like you've increased the total resistance of the circuit. So the answer to this question is decrease. I'm glad we've got the next question, which says, I think, let me just quickly check what the question says. The question says, explain the answer to question 10.1.5. So I've answered that question using my experience that I've got with, not necessarily my experience, but the information, the background that I have relating to circuits. I know it's going to decrease. And reason to that is because I've got an understanding that when you open the switch, you are now converting from parallel to series, and that means you are increasing the total resistance of the resistors of this circuit. So this is, before I continue, this is the V that they are referring to, not this V. As I indicated, I just added this V when I was answering one of the previous questions. So this is the V that they're talking about, which decreases. So that means in answering question, let me just get something to write and answer this question. So 10.1.5, you just choose from its decrease. You had to choose from increase, decrease, or remain the same. So the answer to this question is decrease. And I think this question is allocated 2 marks, so let's just somewhere answer the question. So it's allocated 2 marks, and now we move to question 10.1.6. so it's allocated 3 marks, and the first point is that's what we know, total resistance of the circuit increase. So you can just say total resistance increase. And then the second point, you can indicate that obviously, remember, something happens to the circuit, I mean the current. So remember guys, what happens to the current? Obviously the current now decreases because you've increased the resistance of the resistor when you opened this switch S. So it's also a point that you can indicate to say the current of the circuit decreases. But when it increases, it decreases. So that's the second point that you can mention in your statement when you give the reasons, or when you explain the reasons to your question of 10.1.5. So you can also include a point that the current of the circuit decreases. And again, remember guys, the resistance of resistor R is constant. So that R, it's constant. It doesn't change when you either close or open the switch. You are not in any way influencing the resistance of that resistor. So as a result, the potential difference across this resistor R, it decreases. So that's why it decreases. You can just say R, it's constant, and therefore the potential difference across resistor R decreases. So I just wrote it in that way, assuming that you can be able to just pause the video and write the answer down. So let's see. Obviously, you score a mark for mentioning that point in your statement. You also score a mark for mentioning that point in your statement. So it doesn't necessarily mean that you can use that format to answer that question, but you can give it in a form of an explanation or a statement where you mention those points in your statement, because obviously you won't get the same answer from all learners who will be answering this question. Answers will obviously be different because of the way in which we understand the circuits, and also our way of answering the question may not be the same. But what matters the most is that in your explanation or in your statement, are you covering those 3 points? Then if the answer is yes, then that's when we give you maximum marks, which is 3 marks. So that's how you answer this question of 10.1.6.